Hello everybody. Today we will be going over Design Lab 2 of the Design and Analysis Production Systems, in which we optimize our assembly line from Lab 1. Our team members are Prashant, Yashwant, Luke, Nassar, and Ashwarya. In this lab, by applying various concepts such as just-in-time and Toyota production systems, we will come up with possible solutions to improve the assembly process. The product we were attempting to optimize was a measuring tape. After disassembling it into its individual components, we found it contained 8 unique parts, shown by the table. These parts would require 7 distinct tasks to fully assemble the product. After creating our precedence diagram and measuring the time required for each task to be accomplished, we grouped our tasks into various workstations. For our solution, we decided to go with 2 workstations and 3 operators. The first operator would be assigned to Station 1 with the task of installing the tape on the bottom case, turning it twice to ensure proper tightness, placing the fixer followed by the switch. The other 2 operators would be on Station 2 installing the top case, fastening it to the bottom, and attaching the belt clip. From Design Lab 1 and the data we collected, our optimal solution was a 2 workstation assembly line with 1 operator assigned to Station 1 and 2 operators working on Station 2. Our takt time was clocked at 23.4 seconds per unit with a production rate of 154 units per hour. With these results, the net working time of our line would have been 39 hours at an efficiency of 86.7%, costing around $1,285.68.
Lab 1 was the deformation of the tape spring. After several attempts, the metal bends and the spring would be pushed out of place and become harder and harder to install each following time. The next issue was handling 3 screws with different lengths. This meant the operator would have to spend time each cycle to differentiate and pick the correct screw from the pin. The third problem was the amount of time it took to fully fasten the screw by hand, which caused a bottleneck in our system. The fourth was the poor quality of the actual product. After several assemblies, the pieces lost their shape and failed to pass quality check. And finally, the fifth problem was regarding to the safety of operators. The matrices which we choose to use to measure how effective each of our potential solutions are will be take time, cost, sustainability. Sustainability is defined as development that meets the needs of today without compromising the ability to serve the future generation. Sustainability deals with environmental related issues. Manufacturing a good quality product being our main concern. We redesigned the measuring tape using sustainable materials in order to reduce carbon footprints. We suggest using the plastic of ISO 15270 standard to have a better endurance. To solve the problem, we have 2 options. We can either improve the process, the product design, or both. For improving the process, we need to focus on how to organize the workstation before starting our assembly, so as to make the process faster and easier.
For improving the assembly process, we used various industrial engineering techniques such as Six Sigma, 5S, Total Quality Management, Toyota Production Systems, Just-in-Time, and Pokayoke, which is used to prevent errors. DMAIC is a well-structured procedure used for improvement in process and quality. The letters DMAIC stands for Define, Measure, Analyze, Improve, and Control. The main objective of defined step in DMAIC is to identify the opportunities for improvement and make the project more efficient. In our project, the customer demand is producing 6,000 parts in available time of 40 hours, and per hour demand, this can be achieved in 38.96 hours. But in the practical execution, we found that 1 in 5 products produced is defective. So the waste in our project is mainly due to defective parts and due to idle time. The high defective rate in initial design is addressed by redesigning the product, which is shown in the further slides. Furthermore, the other ways are transportation. Transporting products between processes is a cost incursion which adds no value to the product, and in assembly, transportation cost is less as we have only 2 workstations. Inventory. requires inventory more than demand due to easy wear and tear of spring and unwinding of tape. Motion. Unnecessary motion should be eliminated to increase efficiency. Waiting. There is waiting time after workstation 1 as winding the tape and spinning it needs to be carefully handled. In the measure step, we have measured and calculated various parameters such as takt time, production rate, net working time, cost of production, and efficiency. In the analyze step, the number of operators, standard time, and the idle time is analyzed in each workstation. Furthermore, in our actual execution, we have found a defective rate of 20% in the total assembled products. Poka-yoke is a lean manufacturing process that helps an operator to avoid mistakes. The operators were given training to prevent mistakes in the assembly process and to maintain a smooth flow. These issues were improved in our project and are presented in the following slides.
Possible solutions to our Design Lab 1 problem are listed in the table shown. Each of these problems and their solutions is addressed in the following slides, by which we could significantly improve our assembly line. This brings from our suppliers to prevent it from prematurely failing due to disassembly.
For our various screws, we organize them into rows using 2 clay blocks. The left block contains the screws required to fasten the case together, and the right block has the screws needed for the belt clip. With the screws organized, it reduced the time required by the operator to locate the needed screw and begin fastening it. A significant hurdle to Station 2 was the time it took to fasten all 3 screws to the tape measurer. By replacing our traditional screwdrivers with their electrical counterparts, we can greatly reduce the time required. Not only will it quicken the process, but it will reduce the strain on the operators created by manually fastening the screws. With the reduction in time to fasten each screw, we no longer need the second operator in order to maintain the same takt time. By reducing the labor down to 2 operators, we will be able to cut costs and increase the assembly line efficiency.
The quality of the assembled tapes can be greatly improved by using standard parts and also by providing periodic training to operators to improve the speed and accuracy in their tasks. The learning curve is shown above. Evaluate each operator's performance by giving an efficiency rating and also rewarding them based on the performance. Safety of operators is our number 1 priority. There are 2 possible hazards which we found in assembling this measuring tape. They are: the measuring tape has sharp edges and is not safe to handle. There is a high possibility of unwinding of tape while turning for torsion and can hurt the operators. To avoid such hazards, each operator is provided with safety glasses and gloves and are instructed to wear them on every shift. The cost for buying the screwdriver, gloves and safety glasses are retrieved from Amazon Canada website, which sums up to $33. Assuming $5 profit per product, the payoff period in buying these tools is found to be 0.01538 weeks. Implementing all the suggestions for the issues arise, we were able to decrease task time in workstation 2 by using electric screwdriver, achieving 20.27 reduction in the total assembly time. The number of operators in workstation 2 is reduced to 1, thereby reducing the total workforce to 2 people. This facilitated to achieve a total saving of $428.56. Also, by implementing these solutions, we achieved an improved productivity, better efficiency of assembly line, and also enhanced safety of the operators. In our execution, we found out that 20% of the assembled products are defective. However, this is mainly due to the deformation of spring after repeatedly using it for a number of times and cannot be considered significant. The production rate is found to be 154 units per hour and the total cost of production is $857.14. To control the inventory and to avoid unnecessary costs, just-in-time approach is used. However, a buffer is used in between stations as a safety inventory in case of emergency failures and to ensure smooth flow of the assembly process.
5S concept was invented by Toyota Production System to improve efficiency and input total time. 5S stands for sort, set in order, shine, standardize, and sustain. Sorting parts to its respective bins, also sorting tools in toolbox, aids to increase cleanliness and orderliness in the system, which will ergonomically improve employees' working pace. Dimensions of product quality is weighted by performance, features, reliability, durability, and aesthetics. Performance is quite poor due to spring and screws. The takt time was improved when the product was redesigned by eliminating screws and using screw dispensers. Extras, add-ons that will aid customers to modify the product is not possible in this design. The likelihood that the product will perform as expected with a given period of time is reliability. The tape with initial design exhibited less reliability. The product initially has less durability due to feeble spring quality. The initial design was much appealing, but the new design is better in sustainability aspect.
Design. By using the 5 why analysis, we finally come to conclusion as to implement 4 major changes in product design. They are implementing push fit clips instead of screws. This type of fits can be seen in gun manufacturing done in defense organizations. Fixture, a component present at the end of casing which is used as a guide for tape. This part is considered to be manufactured in top and bottom casing. We are considering entire measuring tape is fiber reinforced polymer. As it is a stronger material, the belt clip is designed to be manufactured while making the rear case. Present helical spring doesn't have high torsion and material quality is very poor. So we are considering high-end heavy-duty torsion spring which can be used for at least 10 power 6 cycles. Then our team got a question as if you implement this design, can the tape measure sustain? So as a solution, we designed the product in CATIA and analyzed in COMSOL softwares. As we can see in the pictures, the front case has holes, in which the clip shaft made in the back case acts as a clip fit when it gets assembled. The holes in the front casing is of 5 mm deep and clip shaft are of 2 mm thickness, which gets good strength to entire casing when it gets assembled. Heavy-duty torsional springs is made of stainless steel, which has a hinge at the top end and point to the bottom end. Actually, the spring is pre-assembled in tape before it receives to main assembly. But for the explanation purpose, we disassembled spring from tape. As we can see, the bottom end of the spring is of straight point end and the top is of hook jointed towards the tape. There is a guider for the spring and a stopper in the bottom case. When the spring is assembled to bottom case, the stopper arrests the spring rotation in clockwise rotation from the bottom end when the tape is pulled. To retain the tape into original position, the tape rotates one anti-clockwise direction and later torsion force acts on it. This type of mechanism generally used in old clocks, which is of key power type. After implementing the new design, this is the entire assembly of measuring tape. New design. This is the clip joint which acts as a push fit. This is the guider for the tape which is manufactured in both top and bottom case. To make sure our design sustains in reality, we used a mechanical analysis software called as COMSOL for our newly designed product. For the clip fits, we imposed a point and surface loads of 2.5 newtons and 10 power 6 repetitive cycles. As a result, there is no deformation in the clips even if it is pushed for 10 power 6 times. To check the quality of our newly designed product, we imposed 2.5 newtons force on all surfaces like X, Y, Z directions on the body. And analysis is done by measuring all the surfaces in COMSOL. As a result, we got to know that even the tape falls from 10 meters and for repetitive cycles, the newly designed measuring tapes work well without any problem and there will be no deformation.
Having optimal lot size is one of the ways to hike process efficiency. What is a lot size? It's a quantity of an item manufactured in a single production run. Costs associated with lot size are setup and handling cost. Production system tries to minimize these costs as much as they can to eliminate waste and hence deciding optimal lot size is vital. Optimal lot size is vital as handling and setup costs are associated with lot size, which gotta be minimum to achieve economic stability, as it reduces lead time carrying cost with improvement in flexibility and quality. Being responsive as well as effective is important in a production system, but it is difficult to achieve due to various uncertainties such as uncertainty in demand. It is either push or pull system adopted in production line having objective of manufacturing qualitative product with low inventory. Push system produces products based on the forecast of demand which creates inventory, whereas pull system is a card based system which produces in upstream only when there is demand from downstream or the customer. Pull system is also called as just in time. Depending upon the product, the system is decided. Ideally, out of numerous solutions, we chose these solutions to be apt. Different production layouts are implemented in industries, but U-shaped assembly line is found to be optimal as it has flexibility of parts movement. Parts to be modified in production line will not have to travel all the way in the line. Also, leisure worker in the production line can hold hand to other worker as his or her workstation is idle for a while. Human brain works faster when it is familiar with what it is supposed to do right next moment. According to human psychology, if things are well organized and easy to reach, work gets way easier and faster. Hence, placing parts in bins and screws on clay in appropriate workstation eliminates confusion to workers and reduction in takt time can be achieved. These are our references and thank you for watching.